Okay, guys, welcome to Chapter 11, Lesson 8. We are dealing with the general binomial expansion. Whoa! Okay, now you remember last time we were together, we used Pascal's triangle, which was this thing, to learn how to find the coefficients in an expansion of a binomial. But suppose I asked you to find something like this to the 20th power. It's going to take forever to get to row 20. So instead, there's another way. In fact, there's another pattern, and let's get right to it. Here are the first four terms of this binomial. So a plus b to the 20th power is equal to a to the 20th, right? That one's always going to be like that. Plus 20 over 1, a19, b, plus 20 times 19 over 1 times 2, a to the 18th, b squared, plus 20 times 19 times 18 over 1 times 2 times 3, a to the 17th, b to the third power, and so on and so on. There's a pattern here. Okay, here's what you need to notice. The b, this is a 1, remember, and there's a 0 there, and a 2, and a 3 on this b, even though it's hard to read. Okay, the number, the exponent of the b tells you how many factors there are in the coefficient. So here, the power of b is 1, so there is 1 numerator and 1 denominator number factor. The coefficient, the exponent is 2, and there are 2 factors on the top and the bottom. The exponent is 3. There are 3 factors and 3 factors. Notice it starts with 20. We get that from the power, 20. Then it goes 20 times 19, 20 times 19 times 18. Starts with 1. Then it goes 1 times 2, 1 times 2 times 3. And you can do the next one, right? What would the next one be? Well, it would be 20 times 19 times 18 times 17 over 1 times 2 times 3 times 4, a to the 16th times b to the 4th. 1, 2, 3, 4. This would be the 5th term. The 6th term would be 20 times 19 times 18 times 17 times 16 divided by 1 times 2 times 3 times 4 times 5, a to the 15th, b to the 5th, because 1, 2, 3, 4, 5, that's where the 5 feeds this. Okay. Now, you know how to do that. Now, suppose I give you another situation. A minus b to the 12th power. Find the first 5 terms. Okay. And then simplify each coefficient. Well, you know you're going to have an a to the 12th, a to the 11th b, a to the 10th b squared, a to the 9th b cubed, 1, 2, 3, 4, and then, oh boy, running out of room, a to the 8th b to the 4th. Okay, so you know how to do those, right? 12, 11, 10, 9, 8, 0, 1, 2, 3, 4. Now, what's the coefficient here on the first one? Nothing. The coefficient here, we're going to start with the 12 on the top and then 1 on the bottom. 12 times 11, 1 times 2. 12 times 11 times 10, 1 times 2 times 3. 12 times 11 times 10 times 9, I'm writing so small here, 1 times 2 times 3 times 4. You get the idea. Now, if the exponent of b is negative, then if the exponent is odd, we're going to have a negative here. So this one's positive, this one's negative, because it's minus b, plus, minus, plus, and so on, like that. That can go on, that's going to go on for another several terms here. Okay, and then you can multiply these through. You're supposed to simplify this, but I'm going to save us the time and let you do that with the calculator. Now, if you'll notice, this multiplication is a pattern. There is a way to write down a repeated multiplication with a descending factor like this. For example, if I write down 4 exclamation mark, that is read 4 factorial. And 4 factorial means 4 times 3 times 2 times 1. 5 factorial would be 5 times 4 times 3 times 2 times 1. So this would be 24. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1, 120. So 4 factorial is this, 5 factorial is this. You get the idea how it works. Now look what happens if we divide our factorialness. So if you have 12 factorial over 8 factorial, can you figure out what would happen? Well, you're going to have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 8 factorial, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then this all will divide out, and you are left with 12 times 11 times 10 times 9. So 12 factorial divided by 8 factorial is equal to that. Now, why is that helpful? Well, it saves us some space. So the 5th term of this last one, 1, 2, 3, 4, this guy right here, this big long one, instead of writing it all big like this, 1 times 2 times 3 times 4, a to the 8th, b to the 4th, what we can do is we said that this was actually equal to 12 divided by 8, so I'm going to do 12 factorial divided by 8 factorial over, reverse this order, 4 factorial. Think about that, make sure it's clear. A to the 8th, b to the 4th, and then since this is divided by, it'll come down here, 12 factorial divided by 8 factorial times 4 factorial, a to the 8th, b to the 4th. That's the 5th term of that expanded binomial. Okay, now if you look right here, this is how to find any term. So suppose that n is equal to a positive integer. So not 0, but 1, 2, 3, 4, 5, 6, and so on. Then what we can do is we can say, okay, a plus b to the n power is equal to a to the n, and then plus n over 1, because remember, if this is 20, we're going to put 20. If this is 12, we're going to put 12 over 1 times a to the n minus 1 plus a b. And then plus, then we're going to do n times n minus 1 over 1 times 2, and then we're going to take away 2 from the a and then put b squared, and so on. So we're going to keep going like that. And that can eventually get worked out to a generalized formula. Suppose you want to find the k term, just any old number, which like the 5th term, then you can do k plus 1 term would be like this. A plus b to the nth power is n factorial over n minus k factorial times k factorial times a to the n minus k and b to the k. So this is, suppose you say find the 5th term, then you would plug in a 4 for the k. Okay, so like this. Let's do an example of what I'm talking about. Find and simplify the 7th term. So we want to find the 7th term in the expansion of 2x minus y to the 10th power. Okay, so instead of dealing with the 2x and the y, what we're going to do is we're going to say that a is equal to 2x and b is equal to negative y, and we're going to start with a plus b to the 10th power. Okay, now find the 7th term. Well, the 7th term is going to be 2 with b to the 6th. So I'm going to jump in right here and we're going to figure this thing out. So 10 factorial, because on the top we're dealing with the 10. And on the bottom, 6 factorial, and then 10 minus 6 is 4 factorial. So 10 factorial over 4 factorial times 6 factorial. See, because notice here, if I want to find the 7th term, 6 plus 1, the 7th term, then I've got to come down here, and this has got to be a 6. This is the 10, 10, 6, and then 10 minus 6. Okay, so here it is again. 10 factorial over 4 factorial times 6 factorial. And then it's going to be a to the 4th and b to the 6th. There it is. And then you can work these numbers out and figure out the numbers. That's it. Oh, a couple other things. 0 factorial is defined as 1. That's important for you to know. Okay, guys, that's the whole lesson. Let me know if you have any questions and get started on your homework.